There's one other place where annotative properties become very important to understand, and that's when using certain types of line types. Today we're going to be exploring the batting line type specifically. Go ahead and open up your drawing. This is our next view that we need to create, and what we see here is that it is a wall section. We can see down below at the bottom that there is a foundation. We can see that there is a wall, and that at the top of all of this that there is a roof condition. This drawing will be printed at 3/4 of an inch equals a foot. That will also be the annotative scale. It's sort of one and the same to say what scale it would be printed at and what the annotative scale means. I can see currently my annotative scale is set to 1/4 of an inch equals a foot. So I need to adjust this. And regenerate my screen. When I do that, I can see that the batting, or this squiggly line here, is representing batting insulation, and we can see that it has been updated to fit in the area. Now I didn't change the line at all. All I have changed here is the annotative scale, and because some of my project is drawn at 1/4 inch equals a foot, and this part of the project is drawn at 3/4 of an inch equals a foot, we have to be constantly vigilant. Which scale are we at currently? Let me show you this again. If I switch this back to 1/4 of an inch equals a foot and regenerate, then those lines change. If I switch it back to 3/4 of an inch equals a foot and regenerate again, they change back. And so what we need to do is understand what's happening here and also how to control it. In order for this to work, you will need a new layer. The layer is called A-DETL-BATT. That is for the batting line type. And the line type for this layer needs to be the batting line type. So go ahead and open up your line type selection window, and you'll need to load this. It's in the menu, and you'll need to load the batting line type and then select it and click OK. Once we've done that, we can start using that line type simply by drawing lines. So I'm going to say L, enter, and I draw a line using, oops, I need to make it current. I need to draw L, enter, and I'm going to draw a line using that line type. And what I can see here is that it's drawing that line with all those curves. That's just 2 clicks, draws that entire shape. Very handy. And the trick here is, how do we control it? What we can see is I've got 3 different pieces of batting on the screen. One that I've just drawn, and then I've got 2 others which are smaller. The question really becomes, look, how do I make it the size that I want? Well, different types of batting have different prescribed thicknesses, and this is how they're going to be delivered from the manufacturer. So we know what we're trying to achieve. In the case of a 2x4 wall, we want to have batting that fits in a 2x4 cavity, and that would be an R13 batting type, and it's designed to fit snugly inside that 4-inch. The ceiling in this case is R19. It's a 6-inch thick batting line type, or if we were drawing an attic that was truly insulated with modern standards, it would be an R38 inch, an R38 batting, and that would be an 11-inch thick line type. So the question, how thick is this line type now? How wide are these 2 curves apart from each other? And to get a feel for this, what I'm going to do is I'm going to just do a distance command, DI, enter, and I'm going to click 2 points, one below and one above, in an effort to measure this. What I can see is that it's about 1 foot 4 inches thick. I'm rounding up slightly, but what we'll notice is that even when we draw this batting for the 4-inch cavity, it's not quite the thickness of a 2x4, which is actually 3.5 inches. So even though we call this a 2x4, it doesn't quite make 4 inches, and the batting is slightly smaller. So over here I'm sort of rounding up as I do this distance, and assuming that that's made to fit inside a 16-inch cavity. So what we have to do here is know, how did it determine this? And what we need to think about is, what is the annotative scale factor? And so if we take 3/4 of an inch equals 1 foot, we know that 3/4 of an inch is a different size than 1 foot. Those are, in fact, very different thicknesses. And if we wanted to actually do the math that would turn 3/4 of an inch into a foot, it would look like this. You would take the 3/4 of an inch and set it equal to 12 inches. Then you would need to understand that there's this imaginary x that 3/4 of an inch is being multiplied by to make that statement true. Well, we need to solve for that x. So in order to do that, the first thing we're going to do is multiply both sides by 4. That means that x times 3 equals 12 times 4, or x times 3 equals 48. And then we'll divide both sides by 3, so that x equals 16. That's actually the same amount of thickness that we're seeing here. What this tells us is that that annotative scale property, which is multiplying everything that has annotative properties associated with it, it's multiplying them by 16 when the scale is set 3/4 of an inch to a foot. So this has been multiplied to be 16 times thicker than its original size. We could verify this if we switch the annotative scale over to 1/4 of an inch equals a foot and regenerate. Then we can see that that line, that pair of batting here is actually, if we do the distance, we'll see that it is close to 48 inches thick. 3'6". It's pretty close to 4 feet. It would fit comfortably inside a 4-foot cavity. Now that's kind of exaggerated because we don't have 4-foot wide cavities that get filled solid with bad insulation, but it's the basic idea. So how big is this batting? It's multiplied by this scale factor. Now the question becomes, when we want to control the thickness of the batting, how do we do it? So what I'm going to do is use the line type scale function to change the size of this batting. And to demonstrate how this works, let me go first back to the annotative scale of 1:1 and regenerate. Notice I'm always regenerating after changing the annotative scale. I zoom in on this so I can see what's going on and run the distance command again to see how thick it is now. And there we go. And we can see that it's approximately 1 inch thick. So, in summary, when the annotative scale is 1:1, it's 1 inch thick. When the annotative scale is 3/4 of an inch to a foot, that is 1:16, then we're getting it 16 inches thick. When the annotative scale is set 1/4 of an inch equals a foot, i.e. 1:48, then it's 48 inches thick. So what we can do is use the line type scale to change the thickness of this batting line type. And watch how this works. If I select the object first and then change the line type scale to 4, it is now, let's do the distance again, di enter, approximately 4 inches thick. However, my drawing isn't going to be printing at scale 1:1. So I need to accommodate for the shift in annotative scale as I draw the batting. I want my batting to be 4 inches thick, but I want it to print at 3/4 of an inch to a foot scale. So I'm going to take this thickness of 4 inches and divide 4 by the 16, which is the scale factor. When I do that, it changes size again, and I'm going to adjust my annotative scale to the correct size and regenerate. And what we see now is that that line type will fit comfortably inside of our wall cavity. Let me stretch this down to fit vertically. And we can see these are actually the same size. What I have done here is taken the bad insulation, which when unaltered by the annotative scale is 1 inch thick. I have multiplied it by 4 because I want it to be 4 inches thick, and then divided it by the annotative scale factor so that when the annotative scale is set, it's correct. You can do the same thing for any thickness. In the wall, we want a 4-inch thick piece of batt with an annotative scale factor of 16. In the ceiling, we want to have a batt insulation, which is 11 inches thick, with an annotative scale of 16. That means that the line type scale for this object is 11 over 16. If the annotative scale were printing differently, let's say I wanted to do a wall section that was larger or smaller, I would need to know the scale factors for those settings as well. And it would be the same formula. The line type desired thickness divided by the annotative scale factor.